Question 1. This is on page 500 and 500 and is it on 600? Oh, it's already in the 600. 607. So we've done our identities worksheet already, in which we have proved. This question also has verify. So I'm going to show you what the difference between verify and prove is. And if you get a verify question on your exam, what you would need to do. So a verify question is almost identical to a prove question. So in A here, you would write out your question, secant theta times 1 plus cos theta equals 1 plus secant theta. And just like a proof, you're going to put a line down to separate your left side from your right side. The difference in a verify question is you actually plug in the value. So instead of theta, I'll write secant of 30 degrees, 1 plus cos of 30 degrees, and on this side, 1 plus secant of 30 degrees. What is cos of 30 degrees? Root 3 over 2. So if cos of 30 degrees is root 3 over 2, then secant of 30 degrees will be 2 over root 3. So in a verify question, you plug in the values and you change things to numbers, and now it's identical to a proof question, except you're dealing with numbers and fractions rather than fractions with sine and cos. And just like a regular proof question, when you have fractions, you'll want to simplify this. And if I simplify this and write both sides as a single fraction, there's a good chance they're going to be the same. So one of the main strategies in proofs is, can you write something as a single fraction? And that's the same, that's the same in a verify question as well. So how do I write a single fraction here? I'm going to need a common denominator. So I change 1 to root 3 over 3 plus 2 over root 3. And on the right side, I have a single fraction. Root 3 plus 2 over root 3. On the left side, can you see that you could change this 1 by multiplying that 1 over 1 by 2 over 2 to get a common fraction? I'm going to get 2 plus root 3 over 2. And now I'm going to multiply these fractions. When multiplying these fractions, can you see that this is one factor, this is one factor, this is one factor, and this is one factor? And when multiplying them, just like we can simplify that because we're multiplying. And those factors are identical. So if your fractions are all multiplying, and you have two factors that are identical, then you can simplify. And if I simplify that, then I've got 2 plus root 3, which is the same as root 3 plus 2. And on the bottom, all I'm left with is root 3. Nope, because this, with the adding, that gets grouped as one factor. And the only way I can cancel that factor out is if it's identical on the bottom. So almost identical to a proof, but now we have verified one value works. And this is why verification is not very useful, is now we can say with certainty that it works for 30 degrees, but we don't know if any other values work, which is kind of useless. If we do a proof, the proof means it works for all angles. It's much more powerful. Okay? But sometimes on an exam, it will get you to verify something. And verify means plug in the answer to see if it works. In this case, it did. And then in part B, it asked us to do the proof. Is it all right if I erase this for now? Everybody who's got this down? So the proof looks the same, except now, oh, I can erase even more. Now we're just keeping thetas and trying to prove it. The first strategy I'm going to use in this question is the strategy of changing everything to sine and cos and writing a single fraction. Question? You plug in the value and check left side and right side separately to see if they work. Okay? Again, just like a proof, you can't move from one side of the equation to the other because you don't know if it's true or not. You're trying to find out if it is true or verify that it's true. So my first strategy is the most common strategy that you're going to use when everything else doesn't work, or if you've tried something else and you haven't tried this strategy, this is a go-to strategy, changing things to sine and cos. So I'm going to change secant to 1 over cos here. I'm going to change secant to 1 over cos here. Yes. Yeah, for verify as well. So now I've changed everything to cos, and once you've changed everything to sine and cos, then part of this strategy is just fraction skills. Can I write both sides as a single fraction? So the right-hand side, we're adding. I'd need a common denominator, so I'd multiply 1 by cos theta over cos theta. And then my denominators are the same, so I get cos theta plus 1 over cos theta, single fraction on the right-hand side. Okay? Here is where it is very tempting to get an E3 error, because you might just, oh, I'm going to just write cos cos without the theta. Anywhere in a proof, if you write something without a theta with the trig function, they'll look everywhere on your page. If you write it like way off to the side, oh, I remember that tan is sine over cos. If you write that off to the side like that, E3 error, even if it's like, that's just like up in the corner. Remember the thetas. So again, this means mathematically it doesn't mean anything without the variable there. Right? It's like taking, I'd said this before, if I take off a letter off somebody's name, right? If I call you ill from now on, you'd probably get sick of that pretty quick. That was bad. That was really bad. Okay, so on the right-hand side, or the left-hand side, I'm multiplying. Can you see that this is all over 1? How do you multiply fractions? Multiply the tops. 1 times this, that'll be cos theta plus 1 over cos theta times 1, cos theta. And we're done. So that strategy, changing things to sine and cos, can make things very quick. For part B, I'm not going to do the verify part. I'm just going to do the proof. Slide this one over. And I'm going to start the proof with the sine and cos. For this one, I'm going to prove in 2 different ways. So if I change things to sine and cos, tan is sine theta over cos theta. Cotangent is cos theta over sine theta. And on the right-hand side, notice how I made the main divide line longer, more prominent, so you remember. You're also, a strategy in doing proofs is to leave some space in between, because you have fractions inside fractions, and all of a sudden, if you write your work too close together, you might steal something from a numerator of one and make it denominator of the other and mix things up. So extra space works out nicely. Here, if on the right-hand side, if I want to get a single fraction. I'm going to need a common denominator for subtracting. And I've got a single fraction on the left-hand side. On the right-hand side, I want to do the same thing. So how do I get a single fraction? Well, first I want to get a fraction divided by a fraction so I can multiply by the reciprocal. I never want to multiply by the reciprocal before I have one fraction on the top, one fraction on the bottom. So how do I get one fraction on the top? Subtracting needs a common denominator. So now I'm going to get cos theta minus sine theta all over sine theta on the top over cos theta divided by sine theta on the bottom. Now I have a single fraction divided by a single fraction. Our fraction rules say we can multiply by the reciprocal. So when you're multiplying fractions, I'd say put brackets around things that are grouped together. So that cos theta minus sine theta, that minus sign makes that one term. Then looking at the rest, when we're multiplying, do we have any factors that are identical? We have the sine theta. We'll simplify with the sine theta, leaving us with cos theta minus sine theta over cos theta and we're done. So the strategy of changing to sine and cos and writing a single fraction, it's going to work 95% of the time to get you the right answer in a proof. And the other 5% of the time that it doesn't work, it's the strategy you have to use first before you get there. So it's really, really an important strategy. That being said, it's not always the fastest strategy. So in this one, okay, we just changed things to sine and cos, and we got our solution. But in this one, sometimes you can look at the left side and the right side of the equation and go, hey, I see a way that I could change something else so both sides are in the same trig function. For example, in this one, I have tangent and cotangent. How hard would it be to write this whole thing with cotangents? What would I have to change? I could just change the tan to 1 minus cotangent. Right? Then both sides would be cotangent. If I do that and get a single fraction, 1 is cotangent over cotangent, to get a common denominator, and then subtract my fractions, oh, I'm done the proof already. That was a lot faster. So noticing that I could change both sides to the same trig function might be quicker. Still use the same strategy of getting both sides as a single fraction, but I was able to prove this one quicker by changing things to the same trig function. Okay. Questions for practice 3, 5, 6, and 7, II.